In the last video, I left with you with this pretty little picture, and the little picture is the little spots on the little left-hand side and the little bands on the little right-hand side, and we're like, hey, the little bands are going to be a little bit better than the little spots over here, and this is what we need to do, and this is what TLC is all like now, but it's not going to require a little bitty instrumentation. It's going to require a lot big instrumentation. Did that make any sense? I hope it didn't, and I hope that just made your head hurt. Either way, banding is more appropriate on thin layer chromatography now. And you can easily see why when you compare the left to the right hand versions of these samples that get applied. And banding is going to help us to determine the RFs maybe a little more precisely. We can go in, we can fine tune, we can zone in on just one area of that band. And it's not just like this big old blobby thing. Then we're like, okay, well, what do we use? What do we go by? That's very difficult, very complicated. So with that said, banding and spray on applications are where it's at. In addition to that, spots and bands can also be compared here. Bands are going to be approved and preferred over spots by most of our pharmacopoeias. And the pharmacopoeia are things, if you've taken CTC 115, those are going to be things like the USP, the United States Pharmacopoeia, the JP, the Japanese Pharmacopoeia, the EP, the European Pharmacopoeia, the BP, which is the British Pharmacopoeia. The list just goes on and on with some of these pharmacopoeias. But they are actually telling us now that if you are doing plate development, you better be doing it eventually at some point in time, if not already. You better be spraying on the samples because this is like the approved, legit method to do things with now. Longer bands, though, do not provide better resolution. And there's a discussion that was had very early on in the days of the implementation of how wide of a band should we go. So what you're seeing in this picture is a 2 millimeter and an 8 millimeter band, and this is wide. So 2 millimeters wide, 8 millimeters wide of sample that has been sprayed onto a plate. What do those things look like, right? Okay, well, if you look at the twos, a lot of people were like, hey, look, the twos are not appropriate here. I take a look at the bands that are showing up, and they look very fuzzy. They look very hazy. I don't really see separation that's taking place. So let's go to 3, let's go to 4, let's go to 5, let's go to 6, let's go to 7, let's go to 8, and we'll just keep spraying application samples on there to see how this looks visually and see if it improves my RFs. All right, well, here's a comparison of an 8 millimeter. And they're like, look, absolutely. I told you if we do longer bands, then our RFs become a little bit better. And what I'm going to say to that is, nah, that's a lie. You're lying to me. That is not true. The spots are going to travel up the same way no matter what. It's just a matter of how the stationary phase and the mobile phase works. I don't care how long the bands are. That doesn't even matter. But the 8 millimeter bands visually appear that they do separate better, but that's just really an optical illusion. Most think that they do, but they do not. The RFs are going to be the same. Now, maybe your eyeballs can see that longer band a little bit better. Maybe your brain can interpret that band a little bit better than if they were short 2 millimeters instead of 8 millimeters. But as far as the comparisons here, the RFs are going to be the same. Those components are going to interact with the stationary phase. They're going to interact with the mobile phase in the same exact way. It does not matter. So we got to kind of make sure that people follow the same standard operating procedure, that they do what they're supposed to be doing. And the pharmacopoeias did set out to clear up this confusion for us that is seen in a laboratory environment. So we'll talk about that in just a second. But there is a preferred width of a band that we do like to see. And this width is kind of like the Goldilocks width. It is a width that we can visually see and feel good about the data and the way that that material presents itself. And then it is also just enough where we do not waste space on a plate, and maybe if we save some space with this sample and that sample and that sample, then it can add up and it can give us an extra lane, or maybe an extra 2 lanes if we're really careful about it, and we can put more samples onto a plate because of that. So there was this conversation that was had very early on what the appropriate width is going to be if we do apply samples onto a plate. A lot of people claimed it was RF driven, but it is not RF driven. It is a visual driven type of situation that happens here. All right. Okay, so now one of the last things that we want to talk about before we end this assignment that's going to be appearing in Canvas is the specific dimensions that these pharmacopoeias are going to be telling us to go with. So what I am going to be referring to right now is the USPNF. So the United States Pharmacopoeia has set guidelines in place. If we are operating in the United States, doing tests in the United States on these products, on these raw materials, on whatever we're doing, if this is what is going on, then there's certain dimensions that we have to make sure that we are upholding, and we've got to make sure that that instrumentation is set up for these appropriate measurements. So here they are. First off, we've talked about getting away from the edges of the plate, right? I mean, folks, this is like me driving. If I'm driving and I am driving up a really crooked mountain and I am on the outside lane going up the mountain, and like I am like almost over the edge, where if I go over that guardrail, it is all over for me. I'll see you in Little Lab Heaven, because I'm not going to be here if I go crashing down. Well, naturally, your gut wants you to stay away from the edge of the road. Stay away from the edge of the guardrail. Don't go all the way. Go more in the center. You feel safer. The same thing is happening here. We need to go inward. So there is an appropriate distance, and that appropriate distance is the X variable that I see on this image. That X variable is 20 millimeters from the left of the center of the first track. What that means is that it's 20 millimeters from the middle of that band to the edge of that plate. That is the appropriate distance that my very first band should be in. Now, I can keep going. I can keep applying sample, and I can keep applying sample until I run out of room. But, you know, over on the right-hand side, we kind of want that as well. We want to make sure that we do not get closer than that, because, again, we're getting closer to the edge of the cliff. So stay away from it. So 20 millimeters, left edge from the center of the very first track that gets sprayed onto the plate. Next up is the Y variable. So the Y variable, if you look at those arrows, it is from the bottom of the plate. How far do you go up before that sample is applied? We've often said that, you know, if we do these by hand, we take a ruler, we go up 1 or 2 centimeters from the bottom, we make our start line. That's kind of where everything's going to be applied. So this is kind of us making our start line. So from the bottom of the plate, that Y variable should be 8 millimeters. The lower edge of the plate to the lower edge of the application position. That is 8 millimeters in total. That is a pharmacopoeia-driven measurement. I need to follow it as I do these plate developments. Next up is L, and I want you to think of L as length. It is the length of the band. So how wide should the sample be sprayed on? And that also is 8 millimeters in band size. 8 millimeter spray, back and forth, and then it's over. And then I move on to the next lane. I do it again, 8 millimeter wide, and then that's over. I move on to the next one. Next up is D. D is the idea that these lanes need to be separated. So how do we do this? Well, the distance is going to be defined as the middle of the first band and the middle of the next band. So the distance between the middle of one to the middle of the other one. That D is the distance. Very easy to kind of remember. And that distance is actually going to end up being a kind of an odd number, an 11.4 millimeter. That is the distance between the tracks from center to center. Not from edge to edge, from center to center. Again, a pharmacopoeia-driven measurement that I've got to make sure that we are matching. Finally, the last variable on the plate is E. And E looks like it is the distance from the bottom of the plate, and it goes all the way to the top of where the mobile phase is going to reach. That is how far I want my plates to develop. E, for the most part, is going to be 70 millimeters in height, unless it states otherwise. The problem here, though, is that it seems like people are so comfortable with centimeters. Keep in mind that 70 millimeters is 7 centimeters. There is a factor of 10 that separates the two. Centi is 100, milli is 1,000, so that's a factor of 10. There are some methods that go a little bit further. There are some methods that go a little bit shorter. Those methods are specifically outlined in the pharmacopoeias, but if it doesn't tell me anything otherwise, and if I'm following those types of tests with those types of situations in place, then it's going to be by default 70 millimeters from the lower edge of the plate. So if I take all of these measurements in mind, how far from the edges, how wide should the lanes be, how separated should the lanes be, what's my total measurement all the way across, keep in mind it's 20 centimeters across this way, and it's 10 centimeters from up and down. So if I take all these measurements and I make my floor plan, and I'm like, how much furniture can I get into the room? Because I want to rehaul everything. I've watched Joanna Gaines off of whatever that show was called. This is going to end up with 15 lanes in total. 15. So that means that you can spray on 15 lanes. Those lanes can be all standards. Those lanes can be all samples. Those lanes can be a mixture of standards and samples. It really just depends on your method that you want to accomplish. But you get a total of 15 spots onto a plate that you can spray something on. No more than 15. Now, you can spray less. If you don't have 15 samples, then by no means do not do 15 samples. That is not a big deal at all. Who cares? But 15 is the max. So, you know as good as well as I do, Canvas is probably going to ask some of these questions. It's going to ask, what does the E stand for? What does the D stand for? What does the X and the Y stand for? Because that is how the pharmacopoeias reference these distances. So it's very important for us to have a basic understanding of what they are referring to. And then it's probably going to ask you for numbers as well. So you got to be ready for it. So how wide are the bands? How far apart should they be? How tall should we develop? What is the typical size of the plate? And then in addition, how many samples can go onto a plate at one time? All of those Canvas. Perfect questions that I can ask in that type of situation. All right, so in assignment number 11, which is the next one, we're going to talk a little bit about the theory of the plate. We're going to talk about how it gets developed, what are the different stages that we need to be aware of that goes on at those moments in time, and we're going to dig a little bit more into the details of how this process works. So stay tuned. Good luck on this assignment. Let me know if you got questions. Bye.